All right, let's talk about one of the toughest things to get right in Go, testing concurrent code. When your program is doing a million things at once, how do you actually make sure it's working correctly? Well, today, we're going to build your toolkit for mastering exactly that. So let's just dive right into the big question, right? Why is this so hard? Why does testing concurrent code feel like trying to nail Jell-O to a wall? You run a test, it passes. You run it again, passes again. Then the third time, for no reason at all, it fails. And you're left scratching your head. That unpredictability, that's the exact problem we're going to solve. So first up in part one, let's get to the bottom of this. We're going to call it the concurrency conundrum. Let's really break down what's happening under the hood that makes this so challenging. And here it is, the absolute root of all our problems, non-determinism. See, normal code runs top to bottom the same way every single time, but concurrent code, not a chance. The Go scheduler, think of it like an air traffic controller for your code, can decide to run your Go routines in a slightly different order every time you run the program. This means a bug might only show up when the timing is just perfect or, perfectly wrong. And this leads us to our first major villain, the race condition. This is that classic, infuriating bug where your tests could pass 99 times in a row, but on that 100th run, two Go routines just happen to access the same piece of memory in a different order, and boom, the whole thing falls apart. It's a bug that literally depends on a race, and you can't predict the winner. And then there's its evil cousin, the deadlock. This is when your program just freezes. Imagine you have two Go routines. Go routine A has a key that B needs, and Go routine B has a key that A needs. Neither one is willing to give up its key first, so they just sit there, waiting for each other forever, and your whole application just grinds to a halt. Okay, so that's the problem. It's a bit scary, right? But how do we fight back? Well, that brings us to part two, your first line of defense. Let's talk about the single most important tool you have in your entire arsenal. Meet the absolute hero of this story, the Go race detector. So how do you use this magical tool? Well, it's almost laughably simple. You just add one little flag, race, to the commands you're already using every single day. Go test, go run, go build, just tack race on the end, and you've activated this amazing defense system. Let's see it in action. Imagine we wrote this function that's trying to be clever, right? It's summing up a bunch of numbers using different Go routines to make it fast. But oops, we forgot to put a mutex around the sum variable that they're all trying to write to at the same time. This code is basically a ticking time bomb. But here's the thing. When we run our test with the race flag, we don't have to wait for that bomb to randomly go off. We get this beautiful, crystal clear report. Look how specific this is. It doesn't just say, uh-oh, something's wrong. It tells us fatal, data race. It tells us there was a write and a read happening at the same time, on the exact same line 29, between Go routine 8 and Go routine 7. It's like a detective handing you the entire case files solved. So how does it even work? Well, here's a pretty simple way to think about it. Imagine your computer's memory is just a shared notebook. The race detector is like a security camera pointed at that notebook. It doesn't wait to see if the handwriting gets smudged and unreadable. The very moment it sees two people trying to write on the exact same line at the exact same time, it sounds the alarm. It flags the dangerous action, not just the bad result. Okay, so this is absolutely crucial. Using the race detector isn't just a neat trick for debugging. It is a professional best practice, period. You should be using the race flag all the time when you're developing. And even more importantly, Go test race needs to be a non-negotiable, mandatory step in your CI/CD pipeline. Now, the race detector is your foundation. It's amazing, but what about those trickier problems, like performance bottlenecks or those deadlocks we talked about? For that, we need to bring out the heavy hitters, the advanced diagnostic tools. And we've really got two main tools here, pprof and the execution tracer. The best way to keep them straight in your head is by the questions they help you answer. pprof answers what? What are my Go routines doing right now? What is using up all my memory? The execution tracer, on the other hand, answers why. Why is my program so slow? Why are these Go routines getting stuck? So let's start with pprof. This is Go's built-in profiler, and it's absolutely essential for understanding how your concurrent app performs. When your app is running slow or it's eating up way too much memory, pprof is the first place you go to find out what's really happening under the hood. Now, pprof gives you a bunch of different reports, but for concurrency, these three are the big ones. The CPU profile tells you where all your processor time is being spent. The heap profile is your go-to for finding memory leaks, but for us, the real superstar is the goroutine profile. It literally gives you a snapshot, a full stack trace of every single goroutine running in your program. If you have goroutines that are starting but never finishing, a goroutine leak, this is how you find them. Okay, but what about those really complex mysteries? For that, we have the execution tracer. If profile is like taking a snapshot photo of your program, the tracer is like recording a full-length movie. It gives you this incredibly detailed visual timeline of your program's entire life, showing you exactly how your goroutines talk to each other, how they get stuck, and how they compete for resources over time. And you might think something this powerful would be complicated to use, right? Nope, it's a simple two-step process. First, you generate the trace file using the -trace flag. Then, you analyze it with gotool_trace. This pops open this powerful visualizer right in your web browser, letting you hunt down those nearly invisible problems like deadlocks or weird latency issues. All right, we've talked about the problems, we've covered the tools. In this final section, let's put it all together and build what I like to call the professional's playbook, knowing exactly which tool to grab and when. Here it is, your ultimate cheat sheet. If you take away only one thing, let it be this. Got a data race? Use the race detector. Every single time. Is your op slow or leaking memory? Grab pprof to find out what is causing the problem. Are you facing a really complex deadlock or some weird latency issue? Use the trace tool to see why it's happening. This is your whole decision-making framework right here. And here is why this is so critical in the real world. You walk into a job interview, and they hit you with this question. How do you test for race conditions in Go? You don't even blink. You calmly say, well, the primary tool is the built-in race detector. We run our tests with gotest-race, and we make it a mandatory part of our professional CI pipeline. That answer right there shows you know how to build safe, solid, concurrent software. So, I'm going to leave you with one final question to take back to your own work, your own projects. Go look at your CI pipeline right now. Is it running your tests with the race flag? If the answer is no, you might just have an army of hidden concurrency bugs just waiting for the worst possible moment to strike. Adding that one flag is the single most effective thing you can do today to make your Go applications better.